Hi guys, welcome back to another Celltomic video, and for today we're doing a chemistry video. So today we'll be covering on metallic bondings. If you want to know more about ionic bonding and covalent bonding, you can find those videos in the link below, or you can access them in the top right hand corner. So let's start with the structure of metals. So metals are giant structures of atoms arranged in a regular pattern surrounded by electrons. So this is what we call a sea of electrons. So these electrons come from the valence shell of the metal atom, which forms this formation of positive ions and the sea of delocalized electrons. So this here are the positive ions of the metal, and here are the electrons. We can see that the positively charged ions are surrounded by the electrons. So this is what we meant by the sea of electrons. So this sea of electrons actually differ from metal to metal. Here we are supposed to draw the metal structure of sodium and calcium. So from the periodic table, we know that sodium is in group 1 and calcium is in group 2. So this means that sodium has a valence shell of 1 electron and calcium has 2 electrons in its valence shell. So now we're going to draw the sodium metal structure. So we start off by drawing the positively charged ions. So sodium, 1 plus, 1 plus, and 1 plus. For this example, we're just going to draw 3 metal ions for each metal. So we know that for every sodium atom, they have 1 electron in the valence shell. So this means that there will be 1 electron in the sea of electrons provided by each metal ion. On the other hand, for calcium, let's first draw in the positively charged ions. So on the other hand, for calcium, it has 2 electrons in its valence shell. So that means each calcium ion will be surrounded by 2 electrons. So we can see that there are twice as many electrons in calcium than there is in sodium. So now let's move on to the physical properties of a metallic structure. So in a metallic structure, it has a high melting and boiling point. It is also a good conductor of electricity and heat, and they are also malleable and ductile. So we're going to see why it's such in the next slide. So for high melting and boiling point. So the high melting and boiling point comes about due to one thing, and it is due to the electrostatic forces of attraction. And these forces of attraction is actually between two things. It's between the metal ions and the sea of electrons. So this is also similar to an ionic bond, but the difference is that in the ionic bond, it's an electrostatic forces of attraction between the positively charged ions and the negatively charged ions. So it's between the two oppositely charged ions. So the strength of the bond is dependent on the number of electrons with each atom. So this means that the higher number of electrons there are in the sea of electrons, the stronger the bond. So what this means actually is that in our earlier example between sodium and calcium, since calcium has more electrons in the sea of electrons, calcium would have a higher melting point and boiling point compared to sodium. So now let's move on to conductor of electricity. So one thing we need to know in order to see whether a molecule or compound is capable of conducting electricity, we need to see whether that particular compound or molecule has free moving charged particles. So what does charged particle means? So charged particles usually mean anything that has a charge. So examples of these are your ions, both positive and negative. You also have your electrons, and last but not least, your protons. However, protons are found within the nucleus of the atom. So this means they are not free moving, so we don't really look at them. So we just look at ions and we look at electrons. So in the case of a metal structure is filled with a sea of electrons. So this sea of electrons means that the metal has free moving charged particles. So that is why they have this sea. So this means that they have the free moving charged particles that is necessary for them to conduct electricity. That is why they are a good conductor of electricity. Furthermore, these electrons are also able to transfer the thermal energy, which is why they are able to conduct heat as well. So that is why a metal is able to conduct electricity and heat, and they are a good conductor of electricity and heat. Lastly, we have come to the malleable and ductile part. So malleable means can be beaten to sheets, and ductile means can be put into wires. This means that the metals are a little flexible. And to illustrate why they are such, I'll first draw the metal atoms. So metal atoms looks like this. So they're all regular shaped spheres, like your solid particles. So all these regular shaped spheres are all sitting on one another in layers. So when we apply a force, let's say we apply a force this way on the center row, they will roll over one another. So this causes a shift in the layers. So this shift shows that they are flexible and they are malleable and they are ductile. So that is why, in order to make metals stronger, we have alloys. So one particular example of an alloy is actually steel. Steel is an alloy made of iron and carbon. In alloy being a mixture, we add in an additional element. In this case, we're adding carbon in it. So this disrupts this regular pattern, or regular layer as we say. So instead of having nice layers of iron atoms, all of a sudden we have giant carbon atoms. They are making this regular structure not as regular anymore, and that is why they are not able to roll over one another as easily anymore. So this makes them stronger. So that's all we have for this video. Remember to catch the other bonding related videos from the link below. So do remember to like and subscribe to us to catch more videos. You can also follow us on our Instagram page. So our Instagram name is actually Celltomic. You can also follow us there. And always remember to stay curious.